Our surface area of square-based pyramids is next. Looking at a pyramid here with a base that is a square, all the sides are the same. So if we were to take and look at the shape that this thing sits on, it's a square. Alright, so what we're going to do here is we're going to take that, we're going to call those sides S, and we're going to square them. Alright, because we're looking at surface area, so we want to think about basically two components. This is the base, S squared, which is the square, of course, and everything else is what we call the lateral surface area, the side surface area, which is basically made up of 4 triangles. And these triangles are, they're all congruent, so it's really simple to calculate the area of one of them. So if I were to take this triangle out, just one of them, and calculate its area, well, it's right here we have side length, and then right here in our problem is the slant height, L. So as we know, the area of a triangle is 1/2 base times height, so it's 1/2 S times L. There are 4 of those, so you have to take that and multiply it by 4. So 4 times 1/2 is equal to 2SL. So that's where this comes from. That would represent the lateral surface area, 2 times SL. So just like with cones, we have to really be careful because there's a huge difference between H, which goes right down the center of the 3-dimensional solid, and then the slant height, which kind of goes down one of the ramps, if you will. It's a little easier to see in this diagram. Right, the height is right down the middle, so it would touch the very middle of the base. So if this thing were a solid, actually made of plastic or something, you wouldn't actually be able to see the height. We would, however, be able to see the L, the slant height, because that goes down the side. Alright, so let's do a few. Number 1, surface area of this pyramid. It's the area of the base plus 2 times S times slant height. Now in this example, everything's given to us. 2 times 7 times 10.6. Everything's nice and easy. So you just type it into your calculator and you get your answer of 197.4 square miles. Simple as that, right? But sometimes the slant height won't be given, and instead we'll be given the actual height, which is H. So in this case, L is given because it goes down the outside, but when the height is given, it's sort of a hidden dimension right down the middle. Alright, so number 2, in this example, we are given the height. So we're given that S is 140, H is 240, slant height we don't know. So we have to figure that out. So what I need to do first, well, let me write my formula. It's S squared plus 2SL. I know S is 140, so it's 140 squared plus 2 times 140 times L. In order to find L, what I need to do is think about what the height actually does. The height goes right down the center of the pyramid and intersects with the base of the pyramid, and it's right in the middle of the base, and that's important. So what I want you to do now is kind of think about this cross section, which is a right triangle, where this is 240, this is L, and this right here would be this distance. So it's just going from here to here. That's not 140, but it's half of that because the height goes down and touches the base right in the middle. So really it's only actually going from here to here. From here to here. You can see that makes a nice little sort of rectangle. Would actually be a square. So your job is to figure out that slant height. So here we go. We have to go over here. It's hopefully pretty easy for you to see what theorem we have to use. It's a right triangle, and we're looking to find the hypotenuse. So the hypotenuse is the slant height. So your job is to calculate that slant height. And if you plug everything in and you hit the square and then the square root, I think you get that it's a pretty nice neat number. Yeah, it's 250. So the slant height, which is L, is 250 meters. So that's what we're going to put right here. We're going to put 250 right there. And we'll just put that all into our calculator. It's a pretty big number again, 89,600 square meters, and we're done. So you can see that there's a little bit of side work involved when you have the height given rather than the slant height. And the key to this, I think, is understanding that you need to take a two-dimensional triangle and extract it from a three-dimensional solid. It's not the easiest thing to visualize, but hopefully that's, if you do enough of these problems, practice problems, you'll be fine. Number three, let's see, we've got, we have H is equal to 18, S is 10, L we don't know. So that just means that we have a little bit of extra work to do to find that slant height. And let's see, we're going to go and think about, we've got ourselves a right triangle, and we need to extract that out of the three-dimensional solid. So here we go. I'm going to bring that out over here, down here, and the height of that thing is 18. The slant height we don't know. The slant height in our picture goes like this. And the bottom of this, from here to here, is not 10, but it's half of 10. Right, if you think about it like this, it's half of 10, which is 5. So you want to go 18 squared plus 5 squared equals L squared. And when you type all that stuff in, you get your slant height. So I go the square root of 18 squared plus 5 squared, 18.6815. And now we're ready to go. We have surface area is S squared plus 2 times S times L. So it's 10 squared plus 2 times 10 times this number right here, 18.6815. And you type that all in, you get your answer. Number 3 is 473.631 square centimeters. So again, just to take a step back and think about what that actually means. Surface area is the amount of stuff that you would have to sort of account for on the outside of this solid. So it's always helpful to think about how much paint you would need to paint the outside of this thing, including the base. Or if it were a gift, how much wrapping paper you would need to actually wrap this gift. Number 4. So no diagram given here. We want to know the surface area of the square pyramid with a base area of 225 square inches. Alright, so what does it mean to have a base area of 225 square inches? Well, if you think about what this formula actually means, right? S squared, that is the base area. The base is a square. So the base area is given to us as 225. So we can just enter that right in there. So if you have a square that has an area of 225. S squared equals 225. To find how long each side is, you just take the square root of that. So we get 15 inches. So S is 15. So I'll just enter that right in my formula. 2 times 15 times L. Alright, so we need to know L, but what else is given to us is the height. The height is 7. Alright, so if I wanted to draw this thing now, I would see if I can draw this. It's not the easiest thing. It's a kind of a short pyramid. Let's see if I can draw this. Something like this. And I have this. This goes this way. It's not too bad. The height is given. The height goes right down the center. And that is 7. The side length we just found to be 15. That's 15. So is this. And what we need to find is the slant height. The slant height goes right down the edge of our pyramid, right like that. And that is, as of right now, missing. So what I need to do is turn this 3-dimensional solid into a 2-dimensional right triangle. So here we go, my height of my triangle. What I'm doing is I'm pulling out this triangle right in here. Alright, this pyramid's standing up straight, which means it's a right angle right here, so that's 7. This is L, and this distance is, again, half of the total side length. Half of 15 is 7.5. So you need to go to your calculator now. We're going to go 7 squared plus 7.5 squared equals L squared, and get yourself a slant height. Your slant height is 10.259. 10.259. So that's what we'll put right in here. 10.259. And then you're ready to multiply all that stuff together and see what you get. $532.774. And that is square inches. Cool. Last one, number 5. Number 5, we're going to go and look at some actual pyramids. These are real statistics for the pyramids in Egypt. So let's read this here. We've got the Great Pyramid was built about 4,500 years ago, and the base lengths are just about perfectly square. So for our purposes, we're going to assume that they're perfect squares, even though they're not quite exactly perfect, but they're pretty darn close. In other words, these angles are all right angles and all these segments are the same. Alright, and that's pretty astonishing considering that it was built so long ago, and you know how many blocks there are and stuff, and how heavy each one was, and they didn't have the technology and stuff. So you know, these things are pretty interesting to look at and to analyze, because they're just about perfect. And let's see, we go down here and it talks a little bit about how quickly the workers had to work, and then it gets into some key information right here. It says today the height of the pyramid is about 455 feet. So that means the distance from here to here, from the top straight down through the pyramid, is 455 feet. And it says that it used to be a little bit taller than that, but with erosion and stuff, things change. I think actually the Great Pyramid of Khufu is the one back here, but it doesn't matter. I think it's this one, not this one. But anyway, it's 455 feet tall. If you were to walk completely around the base of the pyramid, you'd have gone about 3,024 feet. Alright, so what that means is, if we're walking around this thing, right, we start here, we go this way, and then this way, and then this way, and then back to where we started. All right, that's 3,024 feet. That would be, of course, the perimeter of this square. So to calculate one of those side lengths, all you need to do is take 3,024 divided by 4. And when you do that, you get the side length. So 3024 divided by 4 is thankfully a nice, neat number. It's about 756 feet. So that's how long it is on each side. And again, we're going to consider that it's square. So each side is 756 feet long. All right, and it has a height of 455 feet. So I think that's all we need in order to solve this thing. Let's see. So we have H is 455. We have S is 756. We don't know the L. I'm still trying to figure that out. The L, of course, is, if I were to look at this pyramid, it would be the distance straight down one side of this pyramid. So if you were to start here at the top and go down, it's tough to draw, down the center of one of the sides, that will be our slant height. So we need to figure that out. It's this distance right here that goes down the side. Alright, so what I want to do is draw a little picture for myself. So let's see, I'm going to put a triangle and then finish it like that, and then put that there. 756 is this distance. It's also this distance right here. And the height we just read is 455. 455. And we want to calculate the slant height. The slant height goes from here to the top of our pyramid, the apex, and that will be our slant height. So again, hopefully you can see that there's a nice right triangle being formed here. So I want to pull that out and figure it out. It's 455 L, and this purple distance is half of 256. Half of 256 is 378. So get those calculators out, Pythagorean theorem, and see what you come up with. Square that, and I get 591.531. That's my slant height. So in my formula here we go, surface area is S squared plus 2SL. And I want to stop for a second and read my actual question. It's only asking for lateral surface area. So if I were to calculate this whole thing, I'd actually get the problem wrong. Lateral surface area, again, is just talking about the sides of our pyramid. We don't need to calculate the base. So when you look at your formula, get rid of the base and just calculate the lateral surface area. 2SL is all I need. That's the only thing I'm looking to calculate here. So I go 2 times the side length times the lateral, or excuse me, the slant height, which we just found, and type all that stuff in, and we get, let's see, 894,000. 394. And that would be in square feet. So that is the lateral surface area of the biggest pyramid in Egypt, which I think, like I said, is this one back here. If we're looking at this map, I think they're kind of spun around. The one with the cap on it, I think, is actually the smaller of the two. This is the big one that is called Khufu. Right back here. In any event, that would be your answer. Lateral surface area. It's the amount of stuff that makes up all 4 sides. So we're not actually calculating the base of it, just the stuff on the outside.